The system unit. First of all, what is the system unit? The system unit, also known as the system chassis, is a container that houses most of the electronic components that make up a computer system. So here, this is actually a picture of a desktop, and you can see that this is the system unit enclosed in an additional case. All right, in a laptop, you'll find that a system unit is housed with selected secondary storage devices. With tablets, the system unit is typically behind the monitor. Smartphones, they're behind the display screen. And with wearables, they're embedded on a computer chip itself. So again, here with a desktop, this is typically your tower. So the system unit's within it, and then you have your mouse here, and maybe your monitor outside of the system unit. Next, we have the system board. The system board controls the communications for the entire computer system. On a system unit here, it's typically at the bottom of the system unit or along the side. So here, if this is a tower standing up, it's along the side here. Okay. It's also known as the main board or motherboard. It has sockets, slots, and bus lines. Here's an example of a socket. Okay, a socket is the connection points for chips. All right, a socket is a connection point for chips, such as a processor. All right, you also have slots. Here are your slots, which allow you to place adapters on them, adapters such as perhaps a wireless card of some kind. Here's another slot. And then you have bus lines. They're basically lines that allow the different components to communicate data with one another. They carry the information. Next, let's talk about a microprocessor. There are two main components of a microprocessor. The very first is known as the control unit, and the second is the arithmetic logic unit. The control unit, by definition, directs the movement of electronic signals between memory and the arithmetic logic unit, where the arithmetic logic unit helps us add, subtract, divide, etc., find out what's greater than, less than, equals to, greater than, equals to. It does its logical comparisons for us. So it's simply a control unit tells the computer what to do, including the arithmetic logic unit. Word, when used with microprocessors, basically represent the number of bits that can be accessed at one time by the CPU. So the greater the word size, typically the faster the CPU. Let's look at an example. For instance, if you have what's known as a 32-bit word PC, it can access 4 bytes at a time because 8 bits equals a byte. So 8 into 32 would be 4 bytes. We also have what's known as clock speed. With clock speed, it's related to the number of times the CPU can fetch and process data or instructions in a second. All right. Note that sometimes PCs can process those things twice within a clock speed. So make a note of that. You also have what's known as multi-core processors. You can have multiple processors on a PC that can do task, such as working on one app and the other is working on the other. All right, this gives what's known as parallel processing versus what's known as like piping, where you have one processor working on two applications at the same time, and this is really what it's doing. It's swapping a task. And here with parallel processing with multi-core, they're doing it literally at the same time, okay, without it being stopped. You also have what's known as coprocessor microprocessors, and what they are is they are specialty chips designed to improve specific computing operations, such as a graphics coprocessor, helping out with graphics rather than having your regular microprocessor do that particular work. Next, let's talk about memory. Memory here, the first thing that we're going to talk about is RAM, random access memory. With random access memory, what will happen is if you ever unplug the PC, everything in it is gone. So this is your processor, and this is RAM, okay, and this is storage. When you unplug, all right, everything in RAM is gone. Therefore, that's why you're supposed to save your work down on this storage device. Sometimes we also have what's known as cache. It's actually pronounced cache. And typically that's attached to the processor and even right next to the processor. And what it typically holds is frequently used instructions, etc., that the processor uses that's not in RAM, and therefore it's accessed quicker. If you ever need to increase your RAM, you can by having a DIMM, or what's known as a dual inline memory module, which is attached to your system board here. This is a picture of that. If you ever run out of RAM, which is not a good thing, you can use virtual memory, in which your computer will actually take a portion of your storage device's capacity and use that as RAM, which is not as efficient because your computer has the ability to get information from cache the fastest, then RAM, and then your storage device, such as your hard drive. You also have what's known as ROM, or read-only memory. And read-only memory today is basically flash memory. And flash memory, unlike read-only memory, does allow you to delete or update some data, while ROM didn't allow you to do that. And these don't have to be plugged in because they have a battery that keeps that information up to date. Your BIOS, okay, oh, here's flash right here. Your BIOS is an example of what's in your flash memory, your basic input output system data, basically when you start up your PC, where it's checking to be sure all your stuff is working and functional, your peripherals, that's going to be there. Next, we have what's known as expansion slots and cards. Expansion slots and cards, as you can see here, this is the actual card being placed into a slot. All right, they enhance the capacity of your desktop, your PC. They can be graphics cards. They can be NIC cards, such as a network interface card. Okay, this could be a NIC card here. I think it is. Yeah, in which this NIC card is connected through the expansion slots here that allows you to connect to the network. Next, we have what are known as bus lines. Buses here, they're the wires that connect all the devices together. All right. The wider your bus width, it's like a road. Okay, if you can add more lanes to it, all right, the more data can pass from one point to another point. All right, there are two types of buses: your system bus and then your expansion bus. Your system bus connects your CPU to the memory on the system board. Your system bus connects the CPU to memory on the system board, while the expansion bus basically allows you to connect the CPU to other components on the system board, including your expansion slots. All right, examples would be USB, FireWire, and PCI Express. Next, we have our ports. A port is a socket for external devices to connect to the system unit. You probably see these all the time. And one of the famous ports you see is a standard port called the USB port. All right, there are also other ports like HDMI for those of you who perhaps connect your monitor to a laptop. All right, if you ever give a presentation, you may have an HDMI port that you can use to connect to the projector. All right, there are also what's known as a Thunderbolt port, and I believe that's for Apple devices. You have your Ethernet port to give you Ethernet access to your network. All right, there are also specialized ports. One of note would be your MIDI port, where your MIDI port is a special port for musical instruments like your electronic keyboard or your sound card. You also have your VGA DVI for those of you who are not using an HDMI port. All right, and you also have your FireWire ports, and these ports, they have a connector, like a USB port. Here's your connector, and of course they have cabling that allows you to have the peripheral devices used, such as in this case this could be a mouse here. Next we have what's known as our power supply. Desktop computers have a power supply unit located within here the system unit. Okay, so you'll find this here in the system unit that plugs into a standard wall outlet and converts AC power, alternating current, to DC current, direct current, in which the computer can use here, all right, and provides the power to drive all the system unit components. Your laptop will use an AC adapter because it is outside of its system unit and plugs in, and then here it plugs into the wall, called an AC adapter, while your mobile devices may use a wireless charging platform where there's actually no physical connections that are needed to turn AC power to DC power, AC power being the power that comes out of our wall socket. And last we have what's known as electronic data and instructions. It's important to note that our computer typically only understands these two states, on and off. Okay, we can say this is an electrical current here for a 1, and a 0 is no electrical current. And this is what's known as the binary system, where we have this list here, and you can find this in your text. A certain pattern represents something, such as an A or a lowercase a space bar, an enter, all those things. All right, that's the binary system. There's also what's known as a hexadecimal system, because if we as humans were to do this, we need coding that's a little bit more advanced, because this is very tedious. All right. So there's what's also known as a hexadecimal system, which has a different base Binary system will have, I believe, a base 2, while hexadecimal system has a base 16, which is 16 bits rather than just 2 bits. In regards to the binary system, there's what's known as a character encoding scheme. The first is what's known as ASCII, and ASCII can cover the entire American English alphabet in terms of A, little a, etc. And those are typically used with PCs. Okay, at least it started out that way. And then you have ITSC, which are used for mainframes. And then, because we're a global world today, to understand the languages of others, computers can now run Unicode, which can encapsulate ASCII in it. That has more than 128 characters or spaces for us to use that can encapsulate everything under the sun, at least in terms of the human language, by using Unicode and having it adapt to these ones and zeros. So today what we talked about was the system unit. So the system unit here in this picture is in this tower. So if we were to open it up, you can see it here encased in this chassis here. And on that system unit, something very important, which is the system board, lies on it. In this tower, it's against the wall. Okay, and on every system board, you'll have a microprocessor that can be attached via a socket. And our processor communicates with RAM. And we can increase it through a memory module here. Any peripherals, etc. that we want to add, we can have those cards inserted into a slot. These components all talk via a bus line. We use our peripherals, such as our mouse and input device, by connecting to ports. The whole system unit is powered on through a power supply, which takes AC power and converts it into direct current, in which the PC can use. And the PC really only understands ones and zeros represented by a binary system, which we have to have a coding scheme for, from ASCII, ITSC to Unicode, to represent our A's, lower A's, and other symbols from different languages. And that's it for system unit.